Well, we might use probability for a couple of days because I think that's a little bit more interesting than working with just plain old boring Pascal's triangle, because of the fact that we can tie it to a bunch of different things. We can do probabilities that have combinations in them. We can do probabilities that have permutations to them. We can do probabilities that have cards, dice, gambling. Fun stuff. So, what is probability? Probability of an event occurring is always the ratio of success, not failure, over total possible outcomes. And this is something that you guys have all done before. When you start to think about generic probabilities, the easiest thing to think of is how we write, well, what we've done. Yesterday I talked about this. What's the probability of rolling a 3 on a 6-sided die? Well, how many ways can you roll a 3 on a die? 1. So the total number of successes is there's 1 success, I get a 3. Out of how many possible outcomes are there? 6. And that's where we're getting with probabilities. It's the probability of success over probability of failure. Probabilities are generally written out in simplified fraction form, decimals, or percents. Any one of them is fine. Usually, when you're writing these things through, depending on how your calculator spits it out, it's either going to give you the fraction or the decimal. Don't waste your time doing percents. It's not that big of a deal to move the decimal over. I'm fine with it. Okay? Now, probabilities are always within a specific range. Probability of an event is always less than 1, but greater than 0. Okay. The probabilities will always range between 0 and 1. It doesn't mean that they can't equal 0 or they can't equal 1, because if a probability of an event equals 0, what does that mean? It ain't gonna happen. The specific term is ain't gonna happen. Bless you. The probability equaled 1. If a probability equals 1, it's gonna happen. Okay. And again, that's not anything you guys haven't seen before. Right. Just my specific terminology and lingo of ain't gonna happen might not be exactly what you see in a textbook. Good. Just trying to make it somewhat interesting. So let's think about remember how the other day we were walking around with the cards. This is where our cards come back into play, because cards are very easy to work with. Now, Maddie here, she's the queen of knowing how to guess cards, because she got it right. Now, when you start to think about it, the probability, I didn't even explain this. Capital P, that stands for probability. What I throw in the parentheses is what I'm trying to accomplish. That's the event that I'm looking at. I think I just kind of did it, and I didn't really explain it, but nobody said anything, so I just assumed that you understood it. So I thought I would take a second, just reaffirm that you guys are just not nodding politely. Probability of guessing correct card. 2 R's incorrect. Is, well, what's the probability of guessing the correct card out of the deck? 1 out of how many? 1 out of 52. So there's a 1 out of 52 chance of getting it right. So you ready? What do you got?
Check.
Oh, that would have been pretty freaking awesome.
That would have been so
All right.
crazy.
So the probability that she wasn't going to be right would be 51 out of 52. That's the what we call the complement of it. What else could go wrong? What else could happen? All right. All right. Yeah. Yes, you're getting the same right suits here. Okay. Trap. You weren't even close. All right, Vietmar, just pick a suit. We'll make it easy for the young lad. Probability of correct suit. Yeah. How many suits are there in a deck? 4. So the probability of getting the correct suit is 1 out of 4. All right, Vietmar, what are you thinking?
Hold up.
Hold up. You're
We
conversing.
discussed with my group. What do you guys think? Counting cards.
Time's up.
Diamonds. Hey, Brandon, you're out the group.
See, same idea.
Group like that?
You can even just say black or red. Because in the deck of cards, you have 2 colors. You've got black and you've got red. All right, McCann. Black or red? So you had a 50-50 chance. So you had a 1 out of 2 chance of being right. Which means if you guys were wagering, I just took all of your money.
I was close.
You were close, so was Kathleen yet. But you guys still lose.
If we would have done the same thing, I swear, if we would have.
Conferred?
No.
Oh, suit. All right, come on, pick your suit. You still lose. Kathleen? You still lose. Trap? Suit. You still lose. Don't gamble, don't wager. It's not your favorite.
Life lessons.
Life lessons from Murphy. All right, Vietmar, since you didn't pick the suit right, give me the card.
Like the number? Or like
The whole thing.
Queen of Hearts.
Can I go get my glasses from my locker?
That would be a good
He
place.
keeps using
not
the
to
same
keep them.
card. He's cheating. Yeah, you keep putting it at the top.
All right, what is it then?
5 of diamonds.
You're wrong.
See, look, it's.
This 5 of diamonds last time, I think.
Come on, we got things to do.
I want to show you a magic trick.
Braden, take a guess for me.
So I'm just gonna say like the card doesn't even
Nine of
exist.
spades.
So you roll a 6-sided die, which are numbered. Actually, I'm kind of impressed that this textbook still use the word die or dice, because a lot of times textbooks don't anymore because they're evil.
What did
So they use number cube
No.
because they don't want to talk about dice because that implies gambling, and textbooks don't want to do that anymore because people.
Who cares?
I'm with you. So you're rolling a 6-sided die. What's the probability of rolling a 4? 1 out of 6. What's the probability of rolling an odd number? 1/2. There's 3 out of 6 are odd. What's the probability of rolling a number less than 7? 1. Because you have numbers 1 through 6. The probability of rolling a number less than 7, well, yeah, it's going to be 1. You rolled the die. Okay. It's kind of the idea here. There's not a lot of nuttiness so far until we get into permutation combination stuff. And we'll get about that tomorrow.
That's all we can do.
Well, you can do one of the things that we will talk about more tomorrow. I want to just talk about the basics of probability, what's going to be called experimental probability and whatnot, is that when you get into it, you can get really in depth with your probabilities. For example, do you guys even have an iPod anymore?
No.
No. All right. Well, which means that having to ask you guys if you had like an actual CD is even crazier. So you can do stuff where what's the probability if you hit random that it'll play certain songs in an order and all that. There's always different things that can happen.
Oh, there's like the monkey theory.
Monkey in a typewriter?
Yeah.
Write the Magna Carta? Yeah, it could happen if the monkey lives for a billion years, but whatever. So you get what's also called experimental probability. Those of you guys that took the ACT or the SAT stuff probably saw something like this in table format, where some of the times you'll get data, and they're going to give you like a graph. And a lot of standardized tests will say, given this information, what's the probability that a person selected at random is under the age of 45? So if I'm looking at the data set here, what is the probability that the person is under the age of 45? Well, the grouping of people that are under the age of 45 would be over here. That would be the probability, that would be my success. The total then would be all people surveyed. Does that make sense? It's not a very difficult thing, but it's not something that you see a lot in a traditional math class. You've probably seen that with data collection in some science class, I bet, or on standardized tests. That's where this stuff comes up. Okay. Does that vaguely ring a bell? It's not that it's going to be hard. It's just, you got to read it. Okay? You just have to read it. Which gets us to geometric probability. Oop. Do you remember geometric probability? Do you remember anything about geometry?
I hated them.
Do you remember anything about math?
Do you remember, all right, geometric probability.
I remember triangles and angles. It's a target.
I remember stuff from geometry.
I remember like the proofs.
All I remember is
remember the
Proofs were
proofs.
easy.
Some of them were easy and some of them
Proofs were not that bad.
Geometric probability is basically working with areas. Geometric probability is find the area of the favorable region divided by, oops, bless you, divided by the total area of the object. Okay? So if I want to find the geometric probability of landing in a red ring, I'd have to find the areas of all those rings. Means I have to remember how to find the area of a circle.
So like a dartboard, like what's the
dartboards also.
like what?
I knew you were.
Like you can't hit some words you can't hit everywhere. Showing up the wind, scale over how hard if you throw the dart, if it will actually stay in the dartboard.
Let's go.
So we got an apple.
Get up there, dude. I didn't like an apple.
You really want me to shoot this right now?
No.
I
That was
didn't
not
even see
good.
that.
I
Wait.
didn't want to hit him.
Sawyer, put a book on your head.
It's his fault. He's the one who went up there.
Yes!
How did that even happen?
I don't know, but it was great.
Wait, it broke.
Yeah, he did.
So just delete that one.
am the champion. I am the champion. No time for losing, 'cause I am the champion of the world.
What?
Do you keep this in here for like the one time you
Yes. Yes. Do you blame me?
No.
I get to shoot at the dartboard. This is great. So anyway, do you remember how to find the probability of shaded regions?
can you just like throw it up?
I'm assuming just find the areas.
Right.
And add them.
That was so bad.
How is it
You
bad?
gotta like
If we're talking about a dartboard, there's also a possibility.
I see where you go.
We're talking about a dartboard, there's also a possibility that you don't hit the board.
I'm consistent.
See, there was pencil.
See, I was trying to split the arrow.
What's that we have now?
See, that's why going that way. That's why I have to do the crossbow with it. It doesn't work as well. Why? What are you doing?
He's practicing his archery skills with a hand.
I'm trying to be as good as you.
You'll never be as good as me.
What? What? Here, we'll try it with this.
Awkward silence.
You're gonna get a pencil set. Can you just like take off?
All right. So geometric probability.
Go to the offices.
Yeah, post that. Be like Mr. Murphy.
Mr. Murphy shot me.
I shouldn't mouth off in death. So we want find the probability of red. I want to find the probability of landing in the red region. Which means I have to remember how to find areas of shaded regions. Which means I have to remember how to find the area of a circle.
Don't you just find the whole thing and then like subtract?
We have to start subtracting, correct. So you've got 3 rings that you have to find the area of. So what you do is you just start breaking it apart. Going out to the outer ring has a radius of, well, 3, 4, 6, 7, 9. The outer circle has a radius of 9, but then I'd have to subtract the inner circles. Are we okay with that? So the outer ring would be 9 squared pi, subtract 7 squared pi. What's 9 squared?
81.
What's 7 squared?
49.
81 subtract 49 gives you how much?
32.
So the outer ring is 32 pi. You okay with that?
Wait a what? How'd you do that so fast?
The next circle has a radius of 3, 4, 6. So I have a 6 squared pi, excuse me. Subtract 4 squared pi. What's 36 subtract 16? And lastly, the innermost circle has a radius of 3, gives it an area of 9 pi. So my favorable regions of landing in here, the geometric probability of landing in a favorable region is going to be 32, 20, and 9. Add that together and we get 61 pi. So my favorable region, let me move this out of the way for a second, would be 61 pi. Total area would be 3, 4, 6, 7, 9, 12, which gives you a radius, or an area of 144. That's what that was called. Now here's the thing. In your calculators, if you type in 61 pi divided by 144 pi, you will be wrong. Because if you put it with the slashy division, it's going to take 61 pi divided by 144, but then it will multiply it by pi. So you have to be smarter than your calculator here. In this case here, what's pi divided by pi?
7.
Correct. In some other weird world. But in our world, it's just 1. So what we would put in then would just be 61 over 144. And that gives you your geometric probability of landing in one of the red shaded regions. Or in my case, on my first shot, to get the bullseye,
Wasn't that your second shot? You just shot one and you missed.
Isn't it bulls?
my degree says math, and I think that's how that was spelled correctly. Would have been 9 pi. So you start thinking about things like that. Well, the probability that I got a bullseye, well, I am pretty awesome, but the odds really weren't in my favor.
Then there's also the possibility that you hit anywhere that's not a circle.
You know what? I will give Vimar props because he trusted the fact that he could stand here and I wasn't going to hit him. Now we could do something funny.
Look on his head.
No, I got an idea.
Next time, put a picture of Sawyer like over the
Yeah, just like
bullseye.
put a thing on his head and then just be like, this is what happens when you mess with Murphy. That's a giant apple.
Okay, sorry.
That's a giant apple, Murphy. I think that's bigger than Silver's head.
Are you gonna have me shoot?
Sure.
What?
I want to shoot it, Sawyer. I want to
I'm
do
gonna
it.
hit
Wait, move it a
him.
little more to the left.
There.
There you go.
Perfect.
I should have no, I'm
Oh,
gonna
I
hit
got
him
it.
like
I'm sorry.
Oh, Sawyer.
This is really cool.
What happens if I hit him?
Sorry.
No one will know.
Oh,
Sawyer should be scared.
Wait.
Give him something to put over his eyes.
Where's my mask? We have a mask of cloak of.
There we go. And he says to shoot it this way, right?
No. Shoot it like a
No, he
My
says
mask
to shoot
is
it this way because
That's
if
not
you shoot
Murphy.
it this way,
Yeah, he said it helps.
No.
if I hit you, I'm really sorry. But just know it's for bullying me all year long.
I'm not clothing.
What is that?
This was the cloak of protective.
Another crown.
This was the protective gear cloak.
This is another crown.
It's made out of like math.
It's not.
It's made out of the last thing we took a test on.
Take a couple steps back.
It's.
Do you want
It's-
me to hit his face?
Maybe.
Yes.
Sequences.
Everyone
He's wearing a helmet now.
See, he'll be fine as long as you don't hit the eyes. You're less likely to hit
Wait,
the eyes than
you
the
want
eye.
me to shoot it this way?
Yes.
I'm gonna hit him. I can't.
Oh my.
I'll shoot it.
Now, wait. Let's do this. It's a radius of 4.
16 pack. Plus the stem.
This is
I think you need the bigger
Probably
error.
12 by 26.
What's the
I
So-
don't think it's drawn scale.
what's
not-
the area
shut-
of Sawyer's head?
So, the probability that she's gonna land not in the apple,
It's like 100%.
but in the rectangle.
Is like none.
You never know.
Oh my gosh, just shoot it.
Do
Don't
it.
even shoot that hard.
What happens if I
You gotta
hit
pull
you?
back.
I did hit him.
You didn't hit it, but you also.
You might want to back up just a hair, because
Yeah, that's just way too
It's too
close.
close.
it is. I mean,
No.
it's protective gear, but
You know,
Yeah.
It is not
you got the
protective gear. It's a
ball
piece of
upside
paper.
it's protective.
it's protective. Go
If
back.
It looks like a protective vest.
You want me to keep going back?
Yes.
Then he's just gonna hit you in like your
Nope.
leg.
No. All right.
Oh my god. Now he ruins all the fun.
You are
Back
so
up.
right.
Back up. Just back up. Back up.
I'll shoot the bow. The aim is supposed to
Now aim for the apple.
Okay, but do you want it this way or do you want it?
Whatever. Sure.
Whatever you
It's
feel
not an
like.
answer.
Don't get snarky.
Yes.
I think you have.
I think you're safe.
It's gonna like recoil it.
You're worried about getting hit in the head. My money's on Maddie getting hit. Actually, I would duck.
I would have Maddie move a little. I'm okay.
You sure? Myra,
If
you
you already
alright?
hit me,
Like
I
the-
Now, if you
would-
hit Kathleen, I'd be really
Can
impressed.
you put it on the thing? Oh my gosh.
No, I can't even like get it to stay.
It's not that difficult. There's a spot to put it in.
Oh, I didn't see that.
I'll protect you. I'll swat it in case it comes to your face. Okay, I think we're good here.
I think I'm done now.
I think this one is fair the whole time.
What, you want to shoot it at me?
Now.
You want to shoot
No.
it at me? No, because you would hit me in the face on purpose.
You dropped your protective gear.
It wasn't protected, but.
You know, I didn't get this.
You didn't get hit.
Hey, nobody got hit except for the wall.
The wall's a person too.
Greg,
It's a smart boy, actually.
I named the
Whoa,
wall.
wait, can you shoot
I
it
named
at
every
that?
wall in high school, Greg, a long time ago.
Can you hit that one?
If you would like shrink it
Nah, we
down.
just did this more like this.
Ooh, different shapes.
Oh, goodness gracious.
Yep. Let's find the probability of landing in the shaded region. Let's bring this back to the worst thing you guys loved oh so much.
Trigonometry or circles? Or both?
Yes.
Geometry?
Yes. Yes, this is the apple perimeter apple problem.
I don't even remember that.
Perimeter app?
So
There's no perimeter.
these are obviously this is a regular polygon.
Oh, this one was pretty easy.
What's that?
Now, if you
It's not
remember,
like I was gonna aim for your face.
a few things about
Wait, hexagon, apple,
hexagons are the easiest. Now, one thing to remind you guys of here is that one thing to remind you of is that when you're dealing with a regular polygon, the area of a regular polygon is 1/2 perimeter apothome. Apothome, however you want to pronounce it. The apothome is the segment drawn from the center of the regular polygon to the side. It is always the perpendicular bisector of the side. So if you have side lengths of 16, when I draw this down, that gives me an 8 here and an 8 here. Okay. Now, the way that I taught perimeter apothome problems was a little bit different than what Seb and most other people do. Because no matter what, whenever you have a regular polygon, somewhere along the lines you will always have 3 sides connected. Do you agree with me on that? Whether it's an octagon, a nonagon, dodecagon, 30gon, doesn't matter. Somewhere along the lines, 3 sides connect one another. So what I do is this. I draw in my apothome, perpendicular bisector of a side. I draw what's called the radius, and I bring out to the outside angle.
That's really good.
Because in the apothome, from the center to the vertex, is always a radius. Because if you inscribe a regular polygon, the vertices touch the circle. That's why I get the radius. Right. Now, the next thing that I always do is I work with my angles. The radius bisects that base angle of the polygon. So what we do here is we work with what are called exterior angles. How many degrees does it take to get around an object? 360. That's always a truth. 360 degrees is always the sum of the exterior angles. How many exterior angles are there in a hexagon? 6, which means each of these angles on the outside would be 60.
What's the
Yeah. Perpendicular bisector of the side. Now, that means that the interior is 120, but it makes each of these 60, which makes this a 30, 60, 90, and it gives you an 833 for your apple. So the circle has a radius of 16, because 30, 60, 90. So let's see here. We have the area of a circle. Subtract the area of the regular polygon. And the big shape here is the area of a circle. 16 squared pi, subtract 1/2 perimeter, 6 by 16, and then I have 8√3 for the apothome, over 16 squared pi. It's not something you've done in a long time. I do tend to try to keep these things with hexagons and pentagons. I try not to get too crazy with them for you. But if you remember, whenever you're working with these, the easiest thing to do is to start with the exterior angle by going 360 divided by the number of sides and bringing it in. And then it's just a nasty fraction you have to put together. So if you type all that through with a fraction bar, squared pi, subtract 0.5 6 times. There's a pi button. It's right here. It's right above the caret symbol. Divided by 16 squared. Crappy number. 17.3%, or 0.173. So the probability that you would land in the shaded region is 17%. Not unlike landing on the smartboard or hitting the apple off of Sawyer's head.
very challenging to use.
It is. It is a child's toy.
Now, when you have a child's toy that takes a massive
Some competition.
archery.
It's something. It's like the best $2 I ever spent at Walmart. I've had that thing forever. Questions? Cam, you okay? Totally, definitely zoned out there for a while, didn't you? Let's do these.
It's because you were having me shoot.
You
Number
laughed at
7.
that. That's horrible.
At least I'm not Hitler. In another life.
I'm a bully. Everything is trash.
You are Hitler.
Who are you?
At least I'm not Hitler.
You can't.
These are really fast.
Found it.
I don't think we have any combination.
You should rate it.
And you said you are Hitler. Look at this.
Oh, sorry. Sorry. Don't go 38. Those two get into combinations. We'll talk about those. Stop at 34.
What if I showed Murphy?
Okay. Stop at 34 and do 41 instead.
Show us your Murphy. That's hilarious.
What's that?
I remember
I
that.
had
Bullied me.
You sent me the pictures. It's your own fault
You
I have
bullied
them.
me.
Look at this. He
That's-
said
Why are
That's
you
me.
saying Hail Hitler?
I'm not. We're all pointing at the camera. Murphy, my gosh.
She's bullying me. I'm not doing that.
Do you not see the
You're
edits?
pointing at a camera.
There's the Ruski.
Oh yeah.
There's, oh, that's it.
We're all pointing.
But
my
I mean, do you
gosh.
see Sawyer like right in the middle of the picture?
No. Oh my.
That's really
We're all
funny.
pointing at a camera.
I,